Now, the whole point of propositional logic is that we take propositions and combine them to create new statements that are either true or false. So, for example, let's say that I have a proposition P, and here's the simplest way to create a new proposition, and that is simply to look at not P. Okay, and the way we write not is with this symbol, okay, which I don't know quite how to describe it, but you have just a nice little horizontal line and then a vertical line at the end. That is the negation or not. And not P will be true if and only if, okay, P is false. So when P is false, not P is true. When P is true, not P is false. And realize that those are the only two possibilities because P is either true or false. That's part of being a proposition. So this is our first kind of a way of creating new propositions from existing ones. Now here's another one. Let's say that I have two propositions, P and Q. And what I will do is I'll take P, and this is the symbol for and, which looks just like a little wedge. Okay, and P and Q, this will be true if and only if both P and Q are true. So P has to be true, Q has to be true. Okay, so that's a logical and again, I think this one is actually something that you would just know, right? If you say P and Q, that has to be true only when both of those are true. Another possibility is P or Q, which looks like a little v, the logical symbol for or, and this will be, and I'm going to say is false if and only if P is false and Q is false. I'm writing it this way because it has a kind of a nice symmetry to P and Q. Okay. One thing I do want to point out is that when P is true, for example, and let's say that Q is also true, P or Q is true. In kind of natural language, particularly in English, when we use the word or, we tend to mean P or Q, but not both, right? So you might have to make a choice. Do you want to go to the movies or do you want to go to the park? Right? That or means that we can't go to the park and then the movies. In logic, we actually don't do it that way. We just say that P or Q is false only when both P and Q are false. And that's actually a good thing because of the symmetry with and we're going to see that come back later. For now, just simply accept that when we say P or Q, we mean inclusive or, which means that it allows for both of them to be true. The last connected we want to talk about is implication. So we have P implies Q, and actually I'm going to write it like this. P, just a single arrow, Q, okay? Different books do it differently. And this thing is going to be false if and only if P is true and Q is false. So let's look at that case. Suppose that P is true and Q is false, then it's definitely not the case that P implies Q is true, right? You know, it has to be false because we said if P is true, then P was true, but Q didn't happen. So the implication can't possibly be true. So I think is easy to accept that P implies Q is false in this particular case. But what we're saying is that this is the only case in which it is false, and that actually leaves open this possibility. P is false and Q is also false. In that case, P implies Q is actually true simply because P is false. When P is false, it's like it doesn't matter. It's always true. The implication is always true. This surprises a lot of people. But the only thing I'll have to say about that really is that if you wanted P implies Q to be false when P is false and Q is false, then what you'd end up with is something that looks exactly like Q. When Q is true, P implies Q is true. When Q is false, P implies Q is false. And so we wouldn't even need implication.